I am going to explain our project ANFIS model of photovoltaic and fuel cell based hybrid microgrid system presented by Srivani. These are my teammates Surendranath Reddy, Supraja Sudhakar under the guidance of Mr. Palab Suresh Babu MTech, Assistant Professor, Department of EEE, Annamachara Institute of Technology and Sciences, Rajampet. Outline of our project: objective, introduction, existing method, proposed method, system components, software requirements, simulation results, advantages of proposed system, conclusion and future work, references. Objective: the main aim of the project is to reduce the power crisis and transmission losses, to generate electricity using the renewable energy sources, enhance reliability and resiliency. The microgrid technology along with hydrogen fuel cell based system can be used to solve the power crisis issue, optimize cost. Coming to introduction, energy is one of the primary needs for survival of all organisms in the universe. Energy has dependably been a noteworthy need for the everyday human life. A microgrid is a small scale electricity network that connects consumers to an electricity supply. It operates as a self-contained system, providing power within a defined geographic area. PV panels, also known as solar panels, directly converts sunlight into electricity. Lithium-ion batteries are widely used for energy storage due to their high efficiency, energy density, and eco-friendly nature. Existing method. While the PI controller is a widely used control algorithm, it may not be suitable for all applications. The controller's limitations in terms of accuracy, response time, susceptibility to noise and disturbances, and difficulty in tuning and adaptability need to be carefully considered when selecting a control strategy. Limited control accuracy, slow response time, susceptibility to noise and disturbances. Simulation tool limitations, complex simulation models, validation with standard error metrics, data collection from historical sources, basic mathematical modeling of PV panels and fuel cells. Coming to proposed method. 400 volts is the reference voltage and VDC volts direct current. If volts direct currents produce the error signal, then we will use ANFIS controller. Coming to IDC. IDC is may be used or may not be used, but we used for stability purpose. Coming to PID. PID means proportional integral and derivative. PID produces the output. That output converts from switching operation through the PWM controller. PWM means pulse width modulation. The circuit diagram of ANFIS controller. ANFIS means adaptability neuro fuzzy inference system. Fuzzy logic for handling uncertainties. ANFIS is a hybrid computational model that combines the adaptability of neural networks with the interpretability of fuzzy logic. This makes it well suited for modeling complex and dynamic systems like microgrids. Fuzzy logic for handling uncertainties, advanced mathematical modeling and control algorithms, enhanced real-time data collection. System components. Photovoltaic cell. This is the basic tool of our project. In a PV system, the solar energy is converted to electrical energy by using one or more PV models. Mainly, the system consists of panels and various mechanical electrical connectors in order to produce the desired output. The panel are connected in series and parallel connection to provide the desired amount of voltage and current. DC to DC boost converter. For converting renewable energy, a DC to DC converter is an essential component of the microgrid system. The DC to DC boost converter is utilized to provide a constant DC voltage to the DC to AC inverter. The output voltage of the solar cell and fuel cell varies with the irradiation and amount of hydrogen and oxygen respectively. Again, the output voltage of the storage battery is low. Hence, To eliminate the variation and low output voltage, three DC to DC converters with closed loop configuration are utilized to generate a constant 400 volts DC voltage. Next, three-phase transformer. Subsequent to executing all the above models in MATLAB or Simulink, the models are joined together to make a DC bus. The produced DC from these sources is synchronized to a specified DC voltage 400 volts approximately. It is a reference voltage so that one inverter can be utilized for the entire system. The inverter output voltage is then filtered and then filtered output AC voltage is 268 volts. The three-phase voltage is then connected to a three-phase transformer having delta to star configuration for stepping up the 268 volts AC to 4160 volts AC in order to connect the system to the grid. IEEE 13 bus test feeder system. The IEEE 13 bus test feeder system is utilized to test the performance of the proposed system. The test feeder shows some fascinating features. The 13 bus test feeder contains shunt capacitor banks, distributed and unbalanced load, and in line transformers. The nominal voltage of the test feeder is 4.16 kilovolts and it contains two inline transformer and shunt capacitor banks. The parametric value of the transformer and shunt capacitor bank. Battery model. Due to high efficiency, high density of energy and environment friendly nature when compared to lead acid or NICD battery, lithium ion battery is chosen here for the proposed work. The available battery model in the simulation power system is utilized in the work, which is based on the modified Sippert curve fitting model. Next, fuel cell. The fuel cell used in the hybrid system is 6 kilowatts. The stack fuel cell model provided by simulation power system platform is utilized in the system. The parameters of the fuel cell model can be obtained from the simple polarization curve or the data sheet provided by the manufacturer. MicroGrid. A microgrid is a small scale electricity network that connects consumers to an electricity supply. It operates as a self contained system, providing power within a defined geographic area. PID controller. A PI controller uses both proportional and integral control actions to regulate a process variable and bring it to a desired set point. The PI controller works by comparing the desired set point value to the actual process variable value and then adjusting the control signal in the proportion to the difference between the two. ANFIS controller. The ANFIS controller works by taking inputs from sensors or other sources, processing the information using a fuzzy logic system and a neural networks, and then providing outputs that are used to control the system being controlled. The fuzzy logic system uses linguistic variables such as low, medium, and high to represent the input data and rules that relate these variables to the output data. The neural networks, on the other hand, is used to learn the optimal values for the parameters of the fuzzy logic system, making it adaptive and capable of learning from experience. These are the another components of the system: inverter, IGBT, PID, ANFIS controller, PWM controller, microgrid, VDC. Next, software requirements. In our project, mainly used MATLAB or Simulink. Operating systems which is Windows 7, 8 and 10 is available. Processor, any Intel or AMD X35 by 50 processor is mostly preferred. Disk space 2.2 GB for HDD space for MATLAB only, GB for a typical installation. RAM 8 GB per polyspace and 4 GB per core is recommended. Graphics, no specific graphics card is required. Simulation results: state of charge of the battery unit, inverter voltage, battery SOC and voltage, DC voltage, battery SOC and unit waveform. During the load condition, the battery unit discharges in order to supply the load demand. The stage of charge of the battery decreases. It indicates the discharging of it. In order to test the stability of the system in grid connected mode, the proposed system is connected to the 680 bus of the IEEE 13 bus system. This IEEE 13 bus test feeder is available in the MATLAB as a default bus system. Therefore, the load flow analysis of this default bus system is done without and with proposed hybrid system. The load voltage and current while connecting the system with the IEEE 13 bus system are shown. Results continuous. ANFIS controller output, load power, load voltage and current. Now we will show results in MATLAB. This is the input voltage. 400 volts is the reference voltage. ANFIS controller output. SOC, state of charge of the unit. This is our code. System name boost ANFIS 1, type Sugano, version 2.0, inputs, rules, methods, input 1, range, membership functions, output name, range 0 to 1, membership functions, output constant, rules. Now you can see main diagram of our project. This is the main picture of our project. Inverter voltage. So we use auto scale. This 3-phase inverter. This is 3-phase inverter. Load power, DC voltage. The systems, they are inbuilt subsystems 1, 2, 3, something like that. So this is the results. This is the code of our project. So now we will continue the presentation. Results. Advantages of proposed system: improved efficiency, enhanced stability and reliability, reduced operational cost, minimization of environmental impact, real-time decision making, adaptability to dynamic conditions, optimized energy management. Conclusion and future work. This proposed system presents an approximate 73 kilowatts hybrid microgrid system designed with PVFs, fuel cell and battery storage system. In order to test the system's performance in off-grid mode, a 43 kilowatts AC load is connected to the proposed system via a DC or AC inverter. It is shown that the system yields stable output voltage and current. Moreover, the stability of the system is validated by connecting it to the IEEE 13 bus system, and an approximate of 73 kilowatts real power is added to the grid. Under this on-grid mode, the proposed system also remains stable. Hence, the proposed hybrid microgrid system may be the future solution for the ongoing power crisis in the universe. This is the references. Thank you.